What if every twist of a knob, every button press, and every ultrasonic ping from your ESP32 showed up instantly in a database, accessible from anywhere in the world? That is exactly what we're building today. We have 4 different sensors and input streaming live to Firebase, a potentiometer, an ultrasonic sensor distance, and rotary encoder, and a button that triggers random messages every time it's pressed. Whether you're logging analog data, building a remote control interface, or just learning how to push real sensor value to the cloud, this project covers it all. By the end, you'll know how to send multiple data types to Firebase in real time, straight from your ESP32. Let's get into it. For this project, you'll need an ESP32 development board, an ultrasonic sensor, a rotary encoder, a potentiometer, and a push button. For software, just an Arduino IDE and your Firebase configuration, which I have covered in my previous video, linked down in the description. Let's get building. The circuit that we're going to be building for this portion of the video uses 2 components, the ESP32, then the button. Then for the button, the GND pin, which is right here, goes to the GND pin of the ESP32. And one of the leads, which is the opposite to the GND pin, goes to G12, which is the pin that I have associated so that when we click the button, it sends the random message to the Firebase. Next, I'm going to be showing you the code. Now that the circuit has been built for this project, you'll be understanding the code, and inside the code you'll be needing some libraries, which is the Arduino library, Wi-Fi library, then Wi-Fi client secure library, then Firebase client. Next, you'll be needing to give your Wi-Fi credentials, your Firebase credentials, then the email and password that you have set up in the Firebase so that the Firebase knows which user is going to be sending the button message. Next, you'll be needing the 8 messages, which is right here, all 8 messages. These ones will be randomly sent whenever you press the button. We don't know which message will be sent, but it'll be random. Next is the void setup. In that, we have set up the Wi-Fi, the button, then which message to send. But this is where it gets interesting. So the void handle button function uses the button press to identify which message to send, but it'll be a random message. So this function will take care of which message to send at the button press. Next is the void loop. Inside the void loop, you'll be calling the handle button, which is the function. When you call that handle button, then you know, okay, the button has been pressed, and send a random message to Firebase. Next is process data. This one, it'll process all the data that is necessary to be sent to the Firebase. So this is the code. Next, I'm going to show you the demo of the project. Now that the circuit has been built and the code has been put into the ESP32, I'm going to show you how the button press associated with the Firebase so that the random message gets projected. So when I click the button, you can notice that in the Firebase, we can see that ESP32 button clicked and it became orange. What that means is that a new random message has been put into the Firebase. If I do that multiple times, you'll see new messages. I'm going to show you that now. Now I click the button, it says Firebase rocks. Now if I click again, it says ESP32 says hi. And if I do that one more time, it says IoT is awesome. So that means that the random message is working and the code is working so that the Firebase receives a random message every time I press the button. This circuit, you'll be needing the ESP32 and a potentiometer. The potentiometer is wired to the ESP32 using 3 leads. The first lead goes to GND of the ESP32. The middle lead of the potentiometer goes to G34 of the ESP32. Final lead goes to the 5 volts of the ESP32. Next, I'm going to be talking about the code. Then finally, I'm going to show you how the potentiometer value goes to the Firebase. Now that the potentiometer circuit has been built, I'm going to be explaining the code that goes with the potentiometer circuit. So first, you'll be needing a few libraries, which is the Arduino library. Next is the Wi-Fi library, then Wi-Fi client secure library, then finally Firebase client. Those are the libraries you'll be needing. Next, you need a few credentials, which is network, then Firebase, then the email and password so that Firebase knows which one to talk to. Next, inside the void setup, you'll be needing to set up the potentiometer, the Firebase, and then the Wi-Fi. Once you do that, we have this handle potentiometer function. This handles the potentiometer value from changing. Once it changes, it'll send it to the Firebase. Next, this void loop will take care of sending the data to the Firebase from this potentiometer function. Next is the process data. The process data function, what its job is to process the data that it needs to go to the Firebase. For this code, it'll be the potentiometer's value. Once the potentiometer value changes, this process data kicks in. Once it kicks in, it knows, okay, this value has changed and this is what we need to send to the Firebase in this format. Once it does that, the Firebase gets that data and it displays it so that us users can see that data in real time. The circuit has been built and we have coded the ESP32. I'm going to show you the potentiometer in action so that the Firebase can receive the values. It's under potentiometer and then you'll see three things: percentage, raw, and timestamp. Timestamp means when it happened. Raw means the value of the potentiometer, and the percentage meaning like 50% the knob is at or 100%. So if I turn the knob, it shows that it's changing 5, 6 and constantly changing. That means it's fluctuating. But if I keep on turning it to 100%, it'll show 100%. Currently it's at 100%. Now if I put it at 0%, it will show 0%. You're seeing it's changing and it will be glowing. That means the values are constantly changing. So if I keep changing it, you'll see new values, and the raw keeps changing, the timestamp keeps changing, because every time I move the potentiometer, new timestamps, new raw data, new percentages are going to be put to the Firebase DB. Now we need to build the circuit for the rotary encoder to send the data to the Firebase. So I've wired up the rotary encoder to the ESP32 by the following. So the GND pin of the rotary encoder goes to GND pin of the ESP32. Then the plus pin of the rotary encoder goes to the 5 volts of the ESP32. Then the SW pin of the rotary encoder goes to G14 of the ESP32. Then the DT pin of the rotary encoder goes to pin G13. And finally, CLK pin of the rotary encoder goes to G27. Next, I'm going to be showing you how the code works, and finally I'm going to show you the demo of the rotary encoder's value going to Firebase. Now that we have built the circuit for the rotary encoder, I'm going to be explaining the code so that you know how the ESP32 sends the rotary encoder's values to the Firebase. So first, we need a few libraries, which is the Arduino library, the Wi-Fi library, the Wi-Fi client secure library, then Firebase client library. Next, you need credentials from your Wi-Fi, your Firebase, then your email and password so that the Firebase knows which user is going to access the Firebase and send the data. Next, we have these pins set up for the rotary encoder. Then inside the void setup, we're going to be doing a few main things, which is setting up the pins of the rotary encoder, the Wi-Fi, the Firebase, then telling how to send the data. So we have two functions here. First is the handle encoder. This function, what it does is make sure when a new rotary encoder has been twisted, like the knob of the rotary encoder gets twisted, then it knows, oh, I need to send a new value to Firebase. Next is the handle button. Since there's a button on the rotary encoder, when we press it, you need to tell, okay, the button has been pressed. Next is the void loop. Inside the void loop, we have to call these two functions, the rotary function and the button function. When we call those, oh, we know, okay, we called in and the button has been pressed. Also, the rotary encoder's new value going to be sent. And finally, process data. I've told this before, but the process data is there so that we know what data needs to be processed and sent to Firebase. Next, I'm going to be showing you the demo of the rotary encoder. Now that the circuit has been built, the code has been uploaded. Now I'm going to show you the demo of the rotary encoder sending the data to the Firebase. So if I change the knob of the rotary encoder, you can notice that in the Firebase that there are values being changed. And if I keep on changing it, it says values changed, like from 4 it went to 6 because I kept on changing it. Let's say if I go up to 20. If I go up to 20, it says value 20 and it's been orange. Why? Because it knows the new value is there. If I press the button, it will say the button value 21. It's mirroring the value of the knob. So if I say like value 30, 31, then if I press the button, it should say 31. Well, it does. So if I do like 35 or 37, then it will say 37. So it's mirroring the value of the knob. Whenever I change the knob and press the button, those two values are staying the same. The ultrasonic sensor is wired to the ESP32 using VCC to 5 volts, then trigger pin to pin G14, then echo pin to G27, then finally the GND pin is connected to the GND pin of the ESP32. Next, I'll be talking about the code that powers the ultrasonic sensor to the ESP32. Then finally, I'm going to show you the demo of the values of the ultrasonic sensor going to Firebase. Now that the circuit has been built, I'm going to be explaining the code in a few steps. First, we need a few libraries: the Arduino library, the Wi-Fi library, the Wi-Fi client secure library, then Firebase client library. Next, you need some credentials, which is network, Firebase, and your email and password. Next, you need a few pins, which is the trigger and echo, which are defined here as variables. Then next, we need the void setup. Inside the void setup, we'll be doing a few setup, which is the Wi-Fi, then the Firebase, then the ultrasonic sensor. Next is the void handle. Inside the void handle, you'll be handling the data that comes from the ultrasonic sensor, telling when there's a new value that needs to be sent to the Firebase. Next is the loop. Inside the loop, we'll be calling the handle ultrasonic, which is basically the function that takes care of the value changes. And next is process data. Inside the process data, you'll be processing the data like the ultrasonic sensor, and then the Wi-Fi, then the Firebase, and etc. Now that we have built the circuit, coded the ESP32, I'm going to show the demo of the ultrasonic sensor in action. So first, I'm going to be showing you how the distance gets changed in Firebase as I move the object closer or farther away. So I'm putting the object closer to the ultrasonic sensor, and the distance is keep on changing constantly, and every time it changes it glows orange to indicate that the new value has been updated in Firebase. Now some of the values are keep on changing so that we know that it's good. We got the ESP32 sending real sensor data to Firebase, a potentiometer, ultrasonic sensor, rotary encoder, and a button, all streaming live to cloud with 0 servers involved, and adding more sensors is literally just a few extra lines of code. Full code and detailed blog posts are linked down in the description below. If you want more projects like this, subscribe. There are a lot more coming, and if you're stuck on any electronic project, join the Discord. I'm in there and happy to help. More builds and breakdowns are also on Instagram and Twitter. Links are all in the description. See you in the next one.